Hello, my name is Summers, and I will be presenting the final exam. The protective housing is one of the external components of the X-ray tube. The protective housing is lined with lead and made from metal. The lead-lined housing is to provide an additional shield against leakage radiation as well as protection from electric shock. X-rays are emitted isotropically, meaning they travel in all directions. This helps to prevent excess radiation from leaking into the examination room. The protective housing helps to insulate the tube. It includes a cooling fan, which helps dissipate heat. The X ray tube enclosure. Metal enclosures are more commonly used today due to their superior electrical properties. The enclosure acts as an insulator and helps to dissipate heat. It eliminates air from being inside the tube, and if the enclosure gets too gassy, it has a direct effect on electron flow, resulting in fewer X rays being produced and tube failure. The cathode is the negative side of the X ray tube circuit. The beginning process of X ray production and the source of electrons, electrical current passes through the cathode first and then to the anode to eventually convert into X rays. It includes a dual filament and a focusing cup. The anode is the positive side of the X ray tube. It is made from molybdenum, copper, tungsten, and graphite. It receives electrons emitted by the cathode. The anode is a mechanical support for the tungsten target. The rotating anode allows for the electron beam to interact with the larger target area. The rotating anode rotates during exposure and helps to dissipate heat. The target is made out of tungsten and rhenium alloy with a layer of molybdenum and graphite under the tungsten target, which makes the anode lighter and easier to rotate. The target is angled. This design is known as the line focus principle. By angling the target, the effective area is much smaller than the actual area. The advantages of the line focus principle is the improvement of spatial resolution and heat capacity. And the disadvantages is that radiation intensity is greater on the cathode side than the anode side, which is classified as the heel of the anode. Effect. Heel effect. Anode heel effect. The process of X-ray production. The process of X-ray production first happens with electrical current passing from the cathode to the anode. After the filament is heated up, electrons will bounce off the filament and create a space charge. This is due to thermionic emission. Electrons join the electron stream, then start to flow to the anode side of the X-ray tube. The most common would be a rotating anode, and it can rotate due to an induction motor. Then the flow through the then it flows through the anode and hits the focal tract on the tungsten target. Then the selected effective focal spot and then gets directed to the patient, and lastly the image receptor to form an image. The process Bremsstrahlung interactions. Bremsstrahlung derives from a German word that means break or slow down. When created, a projectile electron is slowed down due to the negatively charged electron. Path travels close to the positively charged nucleus. The electron changes direction with reduced kinetic energy. The change in kinetic energy results in the creation of an X-ray photon. This is classified as a continuous because of the direction and different speeds and the different energy levels that the photon can produce. Characteristic interactions. Projectile electrons coming from the cathode ionize a target atom by removing a K-shell electron. After the K-shell electron is knocked out of place, a vacancy is created. The L shell replaces the K shell to neutralize the atom. From then on, the M shell then fills the vacancy from the L shell, and this will continue until all the vacancies are filled. Oh, sorry. And from there, a outer shell electron replaces an inner shell electron, and then a characteristic X-ray is created. Compton interactions. Compton interactions occur at high levels of kVp. In a Compton effect, an incoming photon interacts with an outer orbital electron. The excited electron receives 1/3 of its energy from the photon and then gets ejected out. The photon keeps 2/3 of its energy and then changes direction, creating a scattered photon with less energy. Photoelectric interactions. The photoelectric effect happens when the incident X-ray ionizes the inner shell electron, but as the electron is ejected out, a photon is emitted. As the photon exits the tube, it does not scatter but gets totally absorbed in the patient. After ionization of the outer shell electrons of the atom, the X-ray photons are created. Quantity and quality. The X-ray beam's quantity is directly related to the X-ray tube's current and the quantity of electrons in the tube. Quantity is controlled by adjusting the mass, and an increase in mass changes the amplitude spectrum shape higher on the emission spectrum. The factors that affect quantity is mass. An increase of kVp changes the amplitude proportionally, as well as an increased atomic number, and the two that decrease quality is filtration and voltage ripple. The X-ray beam quality is controlled by kVp. A change in kVp affects the amplitude and position of the emission spectrum. The factors that affect kVp is added filtration. Added filtration hardens the X-ray beam, which reduces low energy photons from exiting the tube. The atomic number of the target material also increases quantity. The only factor that decreases quality is voltage ripple. Differential absorption. The differences of how X-ray photons interact inside a tissue atom of a patient is known as differential absorption. Differential absorption is the difference of X-rays that are absorbed photoelectrically in a patient, Compton scattering, and the ones that are transmitted straight to the image receptor. Beam attenuation. Beam attenuation refers to the reduction of X-ray photons and a reduction in intensity as the beam it passes. X-rays are attenuated exponentially, which means they do not have a fixed range in tissue. X-ray photons are reduced by 50% every 5 centimeters of tissue the beam passes. Scatter radiation and how to control it. Scatter radiation has a negative effect on the quality of an X-ray image. It can affect the image contrast, contrast resolution, Compton interactions by decreasing it and producing image noise. It decreases the visibility of the image, and it can also make the image grayer and duller. The three main factors that contribute to scattering radiation are an increase in kilovoltage peak, an increase in patient thickness, and an increase in projected field size. Scatter can be controlled by beam restricting devices and grids. Beam restricting devices and grids. Beam restricting devices helps to reduce the useful beam to the size needed. It limits the patient exposure. It reduces the amount of scatter produced within the patient. A variable aperture collimator, which is most commonly used in radiography, uses a small lamp and a mirror that is placed by the X ray beam to aid the technologist in positioning and lining up the atomic structure. It decreases the field size, and that helps to minimize scatter radiation. Grids are used to reduce the amount of scatter radiation that exits the patient and reach the image receptor. The primary purpose of a grid is to absorb X ray photons that don't exit the patient, as well as allow image forming X ray photons to pass through the grid and hit the image receptor. The more scatter a grid can absorb will lead to an image that has good contrast. Thank you.